Hello everyone. This session would be for implementing a multi-threading concept in C using p-threads. So let me ask you something. Like if I give you three tasks, compute square and cube, second task is compute factorial, and third is display multiplication table. How will you write this program? So most of you will subsequently say that you will be writing that code sequentially. Like first you will be computing square and cube, then you will compute factorial, and then the multiplication table. But what if I tell you that your CPU can do all three at the same time? And that's where rather threads come into picture. So today we'll implement a real multi-threading program in C using p-threads. So like while we create the threads, first thread would be responsible to compute square and cube. Second thread would be computing factorial, and third thread would be computing multiplication table. All would be working concurrently on the same input. Fine. So let us try writing the program. Dot C. Okay, so we'll write like as usual. We have to include header files. So hash include correct stdio.h, and the other file would be stdio.h. Another file would be unistd.h and pthread.h. Include unistd.h, and as we are going to make use of pthread, so hash include pthread.h. When let us declare a number. So we'll write first function for the thread one. So this would be for thread one function. Correct. So like we'll write it as void star the way that we earlier wrote. So square cube. This will have void star arg. Correct. Now let us write the code. Here we'll declare one integer n. Okay, which will have input initial value to be whatever the global value that it would be having value as, it will have that thing. So printf /n. So this is for thread one. Correct. Thread one square is square of %d is %d. Correct. So we will have here n comma n comma n star n star n. Correct. Similarly, we will write another printf. This would be cube. Cube of %d is %d. So we will multiply this here. Correct. And then as it is a void, so return null. This is for your thread one function. Correct. Now we have to write for thread two. So slash star thread two. Fine. So star slash again void star star. Now this would be for factorial. Factorial. This will have again void star arg. Correct. Then again the similar code. So we'll take this. Correct. So this is given. Then integer fact is equal to 1. So now we have to write the code for I integer I equal to 1, I less than equal to n, I plus plus. And the code would be like fact star equal to I. Correct. Now this would be computing, factorial would be computed, and then we have to just print it. So printf slash n. So we'll take similar case here. This would be like read to factorial of %d is %d. Correct. So this would be fact. Correct. So we are done with this code with respect to second thread. Return null bracket complete. Now we have to write third one. So what was uh, thread was supposed to do? So thread three, thread three function. So it was meant for multiplication table. Okay, so void mult table again void star arg. Right. So again we will take most of the things same, and we will make the changes. So integer n equal to number, correct? And then we have here thread 3 right. I will correct that code, don't worry. Multiplication table is multiplication table of %d is colon slash n double quotes. Now we want multiplication table of n, correct? So this needs to be now printed first. Yeah, this would be first printf, correct? Then we have to write in printf I less than equal to 10 I plus plus printf %d multiplied by %d equal to %d slash n. What is to be written? N I and then n star I, correct? So our code is done. This was for thread 3. So all 3 thread functions are done. Now we have to write the main code and we have to associate these functions with every thread. So integer main, let us declare p thread underscore t, t1, t2, and t3. Correct. So we'll ask for an integer now. Printf enter a number, correct? Slash n. So this would be our message. Then scanf. Now we took global variable as number, correct? Where we are going to read the input. So this number is to be scanned. So double quotes %d ampersand number. So we got the first that number. Now we have to create the threads. Correct. So let us create the threads. P thread underscore CREAD. First thread number, thread T1. Okay. Then null. Then the function name. So function name was square cube. Can take this as square cube. Okay, so I will write it here. Square cube and then null. So this was for thread 1, thread 2, thread 3. So this would be for T2, this would be for T3. So we know this name. So multi-table table, correct? And second function name is factorial. So we'll make the changes appropriately. Factorial, correct? So this is done. Now we have to wait for the threads to complete. So pthread underscore join T1 comma null. Now, for each thread we have to write this T2, T3. Then printf double quote slash n all thread execution is done slash n double quotes semicolon, correct? Then return 0 bracket. Okay. Now here you must have seen what we used here initially is pthread.h because we want to make use of library for thread creation, library functions or API calls for thread function. Then we took integer number, which is a global. Why global? Because we want all threads with a shared access. Correct. Then like a thread 1 would be computing square and cube. Thread 2 would be computing factorial. Now as like each function, if you see this first function square cube is doing mathematical computation independently. Then thread 2, which was meant for factorial, it would be multiplying it sequentially through the for loop. So even though factorial is sequential internally, the thread itself runs parallel to others. And lastly, the multiplication table. So all threads are using the same input but performing different tasks simultaneously. So if I you see the function pthread create, so here like for we have created three threads. So T1, T2, T3 are the parameters passed and appropriately name of the function to be executed. Correct. So that would be function pointer. We have provided argument, attributes, and then thread ID. So thread creation is lightweight compared to process creation, which we understood. Then towards thread synchronization, we are using thread join. So main thread waits until all thread completes. That's why we write this. So for every thread, we have to write it. So this will prevent premature exit and it will ensure that all outputs are printed. So now like one can combine this with like Hopis too. Like one individual Hopis person is asked to evaluate square cube, second is asked for factorial, and third one asks for multivariate table. All would be working at same time. Output order may change because scheduling is handled by the operating system. Correct. So let us save this code and then we'll talk about possible issues. So let us try to compile GCC multiplication table dash 32. Okay, so which files we have used? Should have H. So have I taken small nu double L? Probably. Return none. Okay. Include stdlib advantage. So if it is a warning, then we probably will skip it. So hopefully there is no error. pthread.h multi-table. Correct. So almost all of them are warnings. Correct. Let us see, like, if all of them are warnings. We'll try to correct them definitely, but let us first execute this. Now if I see 4, so you can see like exactly it did the execution. Now let us try to see whether all 3 threads are created or not. Correct. So what we'll do is, like, we are getting this error. Now let us correct it. Let us see like what has been done by us. So if you see, for a square cube, what I have written was void star. But for multiple, I haven't written. That's why the error was. Correct. So if I compile now the code, you will see errors are gone. Correct. Now, if I execute this code, correct, and let us say I am writing input as 5. So you can see output is shown. But how do I see that threads are created? I can see a thread 1, thread 2, thread 3. But are they really created? Correct. So what I did here, I added sleep there. Okay, in each thread. If you see carefully, sleep 10 for each of them. Okay, and probably we'll add it here too, like before thread join. So we'll write sleep 10 for this too, so that we can check the output. So like how like when we execute this, we have to check like how exactly it would be shown. So let us save. Let us compile and then execute. So if I give say 5, I will go here and I will write ps-elf. Correct. So for read out, you would be saying these are the threads created. Now, if I fire again, because program is done, it will come out of it. So you can see like here, the values would be what? Let me do it again. So if I give 5, I will write grep a.out. So you will see, let us check. I will give one more time, 5. You can see that these are the 3 threads. You can see their numbers are same, correct? Only thread numbers are different, 8, 5, 8, 6, 8, 7, 8, 8. So these are the 3 threads we created. Their PID is 7. And that's how rather you generate 3 threads. Fine. So one of them is calculating square cube. And you can see further one more important thing. The thread scheduling is done here. Thread 1, then thread 3, then thread 2. Correct. So if I execute it again, if I give 4, you can see thread 2 was given first chance, thread 1, and then thread 3. Correct. So we'll try it again one more time. So 7. Now thread 1, thread 2, thread 3. So order would be decided by the scheduler. And the command that we used to see the output was this ps dash e capital L F. Correct. Thank you.